And we're live. All right. I'm going to do this beginning intro part one more time, just in case this happens to be the first video that you're looking at for this course. But look below there where it says course description. You will notice that I have put a link to what is called the guided notes, which is what you're looking at right now. These are the guided notes. You can print this out. It looks like it's 3 pages, right? Yep, 3 pages. And this is what I'm about to lecture on, is this thing. So you can print it out and take your notes on that if you want, or might make a good binder type insertion, so to speak. You'll also see there's a link to the homework set. Here's homework 19. Show your factoring. It says it right there in highlighted in this, like, whatever your color that is, bluish. But anyway, you got, I think I made it 3 pages of problems. Yeah, 3 pages. I think it's 20 problems or something like that. Anyway, that's the homework, and that's what you're going to turn into the D2L Dropbox. As for the actual lecture, let's start that right now. So, what are we doing today? Well, now that we've practiced some factoring in the previous 2 lessons, 17, 18, we're going to start putting it to use. And one of the main applications of factoring is to, well, solve equations. Solve equations that we wouldn't be able to solve using the old ways. Remember the old ways. So here's a nice equation you might look at. Right there. The old way was to get x by itself. How to get x by itself? That is the question. You really can't, because those are not like terms. You're not going to be able to put them together. And if you can't combine them, because one's an x term, one's an x squared term, if you can't combine them, that means you're going to have x in at least 2 places. So how are you supposed to get it in 1 place? How in the world are you supposed to get it by itself? You can't. And so how do you do this? Well, you do something else. And that something else is called factoring. And we've factored before. So you see this nice trinomial here? You remember what you're supposed to do with trinomials? You're supposed to think in terms of trying to unfoil. So the right side's still going to be equal to 0. But the left side, we say, oh, okay, let's try to unfoil this. Now, it wasn't that long ago that we were factoring. Remember how this goes? The x squared is what you get by multiplying the 2 first terms together. And the 6 is what you get by multiplying the 2 last terms together. And there's possibilities of 1 times 6 or maybe 2 times 3, right? There's different possibilities. What you do is you just try them, and if it doesn't work, you try another one. And when does it work? It works when you can make your inner and outer products, right? So this is my outer product, it's the O. This is my inner product, it's the I. It's the O and the I in FOIL. So the outer and inner terms are supposed to combine to 7x, and if you look at a 6x and a 1x, those will combine to 7x, especially if I'm specific about it and say that's supposed to be a plus 6x, that's supposed to be a minus 1x. Did I say plus? I hope I said plus. That's a plus 6x, that's a plus 1x. You add those up, you get the plus 7x, which is what we're wanting. So cool. So I should be official. I'm trying to get a plus 1x when I multiply these 2 things together, and I'm trying to get a plus 6x when I multiply these things together. Good. So what do we got here? We got a situation where the left side is basically, well, it's a product. It's 2 things that are multiplied together. I'm multiplying this bubble times this bubble, and I'm getting 0. Now, if you multiply 2 things together and get 0, if multiply 2 things gets you 0, what does that mean? If I had 2 numbers in my hands, I had a number in this hand and a number in this hand, and I said I multiply these, I get 0. Well, one of them's got to be 0, right? You can't get 0 except by multiplying 0 times something, right? You can't multiply 2 times 3 and get 0. One of them has to be 0. One or the other, or maybe both, must itself be a 0. This is sometimes called the zero product principle or the principle of zero products, or it doesn't really need a fancy name. You know what you're talking about. If two things multiply to zero, one of them's got to be zero. That is the whole basis of solving by factoring. That's the whole idea. So we got either x plus 1 equals 0, and I'll just put and or, x plus 6 equals 0, right? One of these two factors, that one or that one, must be 0. And so if you x plus 1 equals 0, well, very quickly you get an answer, x equals negative 1. And if x plus 6 equals 0, subtract 6 on both sides, and you very quickly get an answer, x equals negative 6. We have two answers to this thing. And by the way, that's going to happen a lot when you've got x squared. If you've got x squared, like we do in the next example too, you often get two answers. I'm not going to say always, but you often get two answers. So let's try that again. Looking at this problem over here. There's no way to get x by itself, right? That's the problem. X squared and x, they're unlike terms. They're not like terms. You can't combine them, which means there's no way you're going to get x in just one spot. You're not going to get x by itself. You have to have a different method. So it's a good thing we've been practicing our vectoring, right? So it's a trinomial again. So you recognize that we're going to have to do one of these deals. We're going to have to try to unfoil. Now the good news is it's kind of a friendly trinomial because x squared must be an x times x in the first positions. There's no other way to do it. The 12, well, the 12 could be a couple of different things. And you know, you monkey around, you try a 1 times 12, and if that doesn't work, then you try a 2 times 6, and if that doesn't work, then you try a 3 times 4, and by the way, that's going to work. Because the outer product would be a 4x, the inner product would be a 3x, and those would subtract to give me just x. So what I would want to do is I would want to have a plus 4x and a minus 3x. I would want to add a plus 4x and a minus 3x. Plus 4x means that must be a plus 4. Plus 4 is multiplying this x, right? And if that's a minus 3, then this must be a minus here because we need a minus 3 times this x to give me the minus 3x. So that's our factoring. And don't forget this equals 0. We have an equation that we're playing with. So it equals 0. And so now we can say, okay, you're telling me that when I multiply this thing times this thing, I get 0? Well, what you're really saying is that either the one thing, x minus 3, is equal to 0, or the other thing, x plus 4, equal to 0. One of these things has to be true. So add 3 to both sides here, and you very quickly get an answer of 3. Subtract 4 on both sides here, you very quickly get an answer of negative 4. Again, two solutions. This happens a lot when you have x squared. So I hope you're kind of on to the game here. If you've got something like a trinomial like one of these and you can't get x by itself, this is what you try. You factor. You try to factor. Pardon me. Okay, let's look at this one. Whale, this one, that one. Well, it's one of those trinomials that, you know, it doesn't start with just x squared. If it started with just x squared, I'm always happy because you know if it's just x squared, it has to break up as x times x. The problem with the 4x squared is we don't know whether to break it up as a 4x times an x. Maybe that would work. Or maybe we should break it up as a 2x times a 2x. I don't know. By the way, it's going to equal 0. One of those. So I'm just going to, well, here's the good news. There's only one way to break up a 3, really. It's 1 times 3. Well, I guess it could be 3 times 1. But let's try breaking it up this way, and let's see if I can get the products to work. 3 times 2x would be 6x. 1 times 2x would be 2x. Can I make a plus 4x in the middle here? I can if I have a plus 6x minus 2x. And if that's what I have, then I have a plus 3 here. So that plus 3 times 2 gives me the plus 6. And I have a minus 2x means this must be a minus. So that a minus 1 times a 2x gives me the minus 2x. Okay, cool. So that is my solution, and it equals 0. Don't forget that part, it equals 0. And because it equals 0, that's telling me that either the left bubble 2x minus 1 is equal to 0, or the right bubble, 2x plus 3 equals to 0. So these are my two solutions going to emerge here. So I'll add 1 to both sides here, divide both sides by 2. There's a solution. X could be a half. I'll subtract 3 on both sides. I'll divide both sides by 2. There's an answer. X could be negative 3 halves. Okay, cool. So it's for one thing, it's a chance for us to practice factoring some more, but for another thing, it's a nice way to solve some equations. Here's an equation. What makes this one different? Hey, it's not a trinomial. It's got this big exponent of 3, but whatever. It's not a trinomial. At least we don't have to try on foiling. How should we try to factor this thing? Again, we can't get x by itself. They're not like terms. We have to try factoring. So how do we factor? Hopefully you remember what the very first kind of thing you should always try is, the very top of the factoring checklist, so to speak. You always try to pull out common factors. And if you look at the 2 and the 8, you say, hey, 2's got a 2 in it, 8's got a 2 in it. And don't stop there, because both of these terms also have an x in them. So I can actually pull a 2x out. So if I pull a 2x, the question is 2x times what would give me 2x cubed? And the answer is 2x times, I need another x squared to get that, right? 2x times x squared would give me the 2x cubed. Okay, 2x times what is going to give me the negative 8x? Well, I'd have to multiply by a negative to get the negative, and I'd have to multiply by 4, really. Right? 2x times negative 4 is negative 8x. Okay, so that's so far so good. Equals 0. And that was one kind of factoring we looked at, was the old pull something out trick. And hopefully you're remembering something about this kind of pattern. When you happen to have a difference of 2 squares, you can factor it this way. This is an x squared, this is a 2 squared, so I go x minus 2, x plus 2. Okay, we just did that 2 lessons ago, so that should be pretty fresh. So anyway, now I've got it all factored. Got it all factored out. There's no more factoring to do. Now I notice that I have basically, let's get a different color going here, I got this times this times this. I've got 3 factors here. Remember, factors are things that multiply. These 3 things are multiplying each other. I got 3 factors here. So that means I've got either 2x equals 0, or x minus 2 equals 0, or x plus 2 equals 0. Any one of those equals 0, the whole product's going to equal 0. So from this first one here, if I just divide both sides by 2, 0 divided by 2 is still 0. So one of my answers is just 0. The min in the middle, I can just add 2 to both sides. What did I just do? Add 2 to both sides and get x equals 2. And then, of course, in the last one, you subtract 2 on both sides and you get x equals negative 2. So that was kind of cool. We got 3 solutions. X was cubed. And when x is cubed, sometimes you get 3 solutions. Pardon me. So that's 4 down. All right, what's going on the next page here? So I'm kind of summarizing a little bit by saying the goal here is get a factored form equal to 0. If you look at all of these previous examples, that's what we got. We got a factored form equal to 0, then we got our solutions. We got a factored form equal to 0, then we could get our solutions, right? That's always what we were doing up here. Get a factored form equal to 0, we can fly. Now if you look at this problem here, I've got a factored form. Oh, it's not equal to 0. Dang it. So we're not ready to go here. It doesn't work to say that if I got 2 things multiplying to 15, then maybe this one has to be 1 and this one has to be 15. That doesn't work, because for all you know, this one's a 3 and this one's a 5. You know, this bubble's a 3, this bubble's a 5. Or for all you know, the first bubble's a 2, the second bubble's a 7.5. I mean, there's too many ways that you could do it. So it only works when you have a 0 on the right. You have to have a 0 on the right. So if you have a 0 on the right, you can say one of these has to be 0. So what I'm going to have to do to get a 0 on the right is I'm going to have to subtract 15 on both sides. Of course, that kind of wrecked my factored form. This is not factored form anymore. This is, well, these are multiplied, but that's a big subtraction. So this is not a big multiplication anymore. So what I'm going to have to do is I'm going to have to FOIL this out. X squared minus a 3x minus a 1x minus times minus is plus a 3. Bring down the minus 15. Okay. Recombine some terms. Oh, that's an x squared. Whoops, whoops, whoops. Recombine some like terms here. I've got x squared. The minus 3x and the minus 1x will give me a minus 4x. And then the plus 3 and the minus 15 will give me a minus 12. That equals 0. Well, that looks friendlier anyway. It's just a little old trinomial. Starts with x squared. It's a friendly trinomial. I like those. So we know that the x squared has to break up as x times x. So you have to ask yourself, how am I going to break up the negative 12? And you guess a few things, and pretty soon you'll end up with this combination. Notice I've got an outer product of plus 2x, and I've got an inner product of minus 6x. And the minus 6x with the plus 2x would combine to give me the minus 4x in the middle. So that part's working. And then the minus 6 times a plus 2 would give me a minus 12. So that part's working, right? You got to make sure it's all working. And it is. It's all working. So let's get this stuff out of here. We don't need that anymore. It works. There's the factored form. Breaks into just two possibilities. Either x minus 6 is 0, which I think you can see x must be 6 in that case, or x plus 2 equals 0, in which case x must be negative 2. So there's our two solutions. So again, factored form on the left, fully factored form, I suppose I should say, fully factored form on the left equals 0 on the right. Next example. Well, again, that's not really a factored form. You need to notice that, okay, yeah, this is multiplying, but that's a subtraction. That wrecks it, man. It's not a factored form, really, on the left. So the only thing we can do is try to massage it, manipulate it a little bit, try to make it factored form. So if we're going to change it, one way to change it would be to FOIL this out and then try to recollect terms. So x squared plus a 1x plus a 2x plus a 2 minus a 12 equals a 0. So I've got x squared plus a 3x here, right? And then these give me a minus 10. And that equals 0. A nice, friendly trinomial once again. And maybe you should just kind of try to FOIL that yourself real quick. Pause the video if you need a moment. Unpaused already? Okay. Well, you know the x squared must be x times x. It has to be. There's no other way. The 10, it turns out you want to use a 5 and a 2. You could use like a plus 5 and a minus 2. Yeah, that works. Notice I've got a outer product of minus 2x, an inner product of plus 5x, and then a plus 5x combined with a minus 2x does give me a plus 3x. And also a plus 5 times a minus 2 does give me a minus 10. So it's all checking out just swell. So I can basically get rid of that now. We don't need that anymore. So there's my fully factored form. So actually, we're pretty much there, right? Either this is equal to 0 or this is equal to 0. And again, if x plus 5 is equal to 0, all you'd have to do is subtract 5 on both sides. X must be negative 5. And if x minus 2 is equal to 0, all you'd have to do is add 2 on both sides. X must be 2. Two solutions again. You having fun yet? I hope so. Hey. Okay. Let's look at this one. Now, careful you don't just get the deer in the headlights effect, right? Part of what you need to train yourself to do in any kind of math situation is when you look at something, don't panic. I'm saying that because I just watched the Hitchhiker's Guide to the Universe. If you've seen that, it's don't panic. Anyhow, so we've got this bunch of stuff. It looks like the exponents are going to be high, and you're like, oh my God. But the thing to notice really is that there's no way we're going to get x by itself because this is like a 4x cubed, and then we're going to have x squared terms, and no way we're going to get x by itself. So we should try to get that factored form equals 0. We got the equals 0. That's good. The left side is not a factored form because really it's an addition. Okay, these two multiply, but that's an addition. So we're going to have to massage this equation, or yeah, we have to massage this equation, try to make it look a little decenter. Yeah, so let's distribute, maybe recombine terms and see what we're looking at. So 4x times x squared is 4x cubed. 4x times a negative 15. 4 times 15. Well, if you double 15, it's a 30. If you double it again, it's a 60x. Then we've still got this plus 14x squared, and then we've still got this equals 0. Okay. One thing you want to do is you want to notice these exponents are kind of out of order. You want to put them in order. That's called standard form when you do that. Put the big exponent first, then put the term with the next biggest exponent, then put the next term. Okay, that's a little bit better. Standard form is always going to be easier to factor. Now, it's still a big trinomial, but before we jump into our guessing and checking and stuff, remember the first thing you want to do is you want to look at all your terms and say, do they have anything in common? They're all even numbers. I can at least get a 2 out. Can I get a 4 out? No, 4 doesn't go into 14. Well, I can get a 2 out. That's getting somewhere, right? So I'm going to pull a 2 out of all of them. But then notice also, I got some x, I got some x, I got some x. If I got some x in all 3 terms, I should pull some x out. Now, how many can I get? Remember, you always go with the smallest exponent. And the smallest exponent is just a 1, really. So I can only pull out 1x from all these terms. But still, I can pull it out. I should do it. So 2x times what would give me the 2x cubed? It would be, well, I'd have to multiply that by 2x squared. 2x times what gives me the 14x squared? I would need to multiply by a 7x. 2x times what gives me a negative 60x? I would have to multiply by a negative 30. There we go. Boy, taking that 2x out sure made a difference, didn't it? Doesn't that look a little friendlier? This thing in the middle anyway looks a little friendlier, right? Still going to have to unfoil it. Now don't lose the 2x, that's there. It stays there. But I want to get ready to unfoil this thing in the middle. Now this is not so unfriendly, right? Because it's not x squared, but it's 2x squared. There's only one way to break up a 2x squared, and that would be 2x times x. So you got to monkey around with the 30, trying to get a plus 7 in the middle. You might want to pause and try this one yourself. It's good practice. Pause. Unpause. Okay, let's see. What's going to work here? Trying to get a 7, huh? Is this going to work? I'm thinking I should have a plus 12x and a minus 5x. Yeah, that'll work. That's what does it for you. So we got 3 factors. 3 factors. This times this times this equals 0. So one of those things has to equal 0. So take it one at a time. 2x equals 0, or maybe 2x minus 5 equals 0, or maybe x plus 6 equals 0. We're going to end up with 3 solutions. If you divide both sides by 2, you end up with, well, 0 divided by anything is still 0. Here I'm going to add 5 to both sides first, then I'll divide by 2, and I'm going to get x equals 5 halves. And here I'm just going to subtract 6 on both sides, get x equals negative 6. Cool. This next problem, I wonder if you just want to pause and try that one yourself. Try the whole problem by yourself. Pause. Unpause. Okay, so first thing I'm noticing is that I don't have a 0 over here. That term's got to come to the other side. So I'm going to subtract that on both sides. And actually, let me tuck it in between these 2 terms over here because I want to have this thing be in what's called standard form, right? I got the big exponent, the next biggest, and then like that. That's called standard form. It's always easier to factor those. This is a trinomial. It's not the friendliest of trinomials, but it is a trinomial. So you know you're trying to unfactor somehow. How do you break up a 4x to the fourth? What times itself? Well, you could be thinking in terms of either a 2x squared times a 2x squared, or you could be thinking in terms of a 4x squared times a 1x squared. Which one? Question mark. Which one? We don't know. But I'll give you a tip. I notice when I do a lot of these trinomials, and I've done a lot of these trinomials, is that when you have a big number in the middle, you probably want to use big numbers everywhere else. So the 4x to the fourth, I want to take the big 4x squared times the x squared. I'm not guaranteeing this always works, but it's just, it just seems to work that way. If you get some hunkin' number in the middle, think of a 4 times a 1, maybe even a 9 times a 1 for your factors. All right, what the heck just happened there? Wish I had a redo button on this thing. I don't seem to. Anywho, I'm going to try to break up the 4x to the fourth as 4x squared times x squared. Now the 9, hey, you know what? Can you see this right now? If you do it, let me change colors. If you do it this way, your outer product is up to 36x squared. See, that's getting us close to the 37 that we want. Ooh. And then here I've got the 1x squared. So my inner and outer products, I'm aiming for a negative 37, and I can get that by adding a negative 36x squared and a negative 1x squared, which means that this should be factoring like this. Awesome. Huh, we did it. But wait, hey, this is happy times. You know why? I got differences of squares here. That means I can factor some more. Factoring's fun, right? I can factor some more. This is a 2x being squared minus a 1 being squared. So you remember how you factor that? You would say 2x minus 1, 2x plus 1. Over here we have x being squared minus a 3 being squared. And so that would factor as x minus 3, x plus 3. And this all equals 0. So you've got, count them, 4 factors. 1, 2, 3, 4 that multiply and equal 0. That means one of them is going to have to equal 0. And make a long story short, you can solve these all out the long way. What you will end up with is both a plus 1/2 and a minus 1/2. So I'm just going to, as a shortcut, say plus or minus 1/2. You're going to end up with a plus 3 and a minus 3. So as a shortcut, I'll say plus or minus 3. 4 solutions to that thing. Whoa, that's fun times. All right. I've shown you how to solve by factoring. That pretty much is the lesson. Remember all your kinds of factoring, pulling out common factors. Remember the difference of squares idea. And for sure, make sure you can factor trinomials by unfoiling. Get a factored form equal to 0, and you can fly. Now I want to end with these two special situations. They're special because every now and then these come up, and every now and then I'm saying the same thing to students. I'm saying, hey, you know what? So let me do the hey, you know what part right now. So, hey, you know what? I want to show you something that's almost works. I'm going to actually write that down. This almost works. It doesn't quite, but it almost works. I want to show you what happens if you're tempted, as almost everybody is, to say, hey, you know what? I'm going to cancel 2x on both sides. So the 2's cancel, the x cancels into the x cubed, and I'm getting x squared. And here the 2 cancels into the 50, giving me a 25, and the 2 x's cancel. Hey, look at that. Now I'll just take the square root of both sides, and I'll get 5. Yay. Okay, there's actually not one, but 2 problems with this. The first problem is that, okay, if you want to take the square root of both sides, what you really should do is go like this, plus or minus the square root of 25. You get 2 answers. You get plus or minus 5, okay? plus or minus 5. Because look at the question here. The question here is, what can I square to get 25? Well, you can square a 5 to get 25, and you can square a negative 5 to get 25. So there's two things that you can substitute there to get 25. So that's the first thing. Just make sure that whenever you're taking the square root of both sides of an equation, that you're doing a plus or minus like that. Okay, but there's actually something else that's sneaky, but this is why we solve by factoring. Wait, solve by factoring. Solving by factoring is always the safest way to fly. If you can solve by factoring, that's a good idea. It's the safe way. So if I solve by factoring, how would this look? I'd have to take the 2x cubed equals 50x. I'd have to make the right side equal to a 0. So first I would subtract the 50x on both sides. This would be factoring type 1. Pull out a common factor. I can pull out a 2, I can pull out an x, leaving me with an x squared minus 25. And then I have a difference of squares, so that would factor as this, right? X squared minus 25 gives me the x minus 5, x plus 5. Okay, cool. So notice that I ended up with this times this times this equals 0. So either 2x is equal to 0, or x minus 5 is equal to 0, or x plus 5 is equal to 0. I'm getting not 1, not 2, I'm getting 3 answers. X could be 0, x could be 5, x could be negative 5. So I do get those two answers, the same as I got up here, right? Those match. But notice I'm also getting x equals 0. I lost that. When I divided by x, I lost my solution of x equal to 0. Bummer. So you're safer factoring, okay? I'm going to actually write this as a rule. Never divide or cancel x. Never, 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 never. The obvious reason is because, oh man, I lost a solution. But there's actually a bigger reason. Hey, we just figured out that x could be 0. Well, what happens when you divide things by 0? Bad things happen when you divide by 0. It's not even defined. You can actually end up with like wrong answers to things if you have a division by 0 mistake in there somewhere. So never divide by x, because x might be 0. And you might lose a solution anyway. It might be 0. Divide by 0 is bad. Okay, point made. Never cancel an x. Never, never, never. All right, on to the next problem. One more problem. This one, you're going to be tempted to, you look at that and you say, well, it equals 0, but again, it's not really a factored form because of that subtraction there. And the temptation is to FOIL. I'm supposed to say the word to. Tempted to FOIL and recombine terms and factor, right? That's what you're tempted to do, and you wouldn't be wrong. So go ahead and do it that way if you really like. But I got a shortcut for you. What makes this shortcuttable is that the x is in a parentheses here. It's not quite by itself, but it's kind of by itself because it's in this parentheses. You can get the parentheses by itself. And watch how nicely this works. So I'm going to have a 3x minus 4 in parentheses. I'm adding the 16 on both sides. Oops. I'm adding the 16 on both sides, so I get that this equals 16. And now I can do the old take the square root of both sides trick. Don't forget your plus or minus. But take the square root of both sides trick. Watch how nice this is. Basically, the square root cancels the square, and so you end up with 3x minus 4, right? On the left side, you'll end up with plus or minus the square root of 16, which is 4. Now, that's not a bad-looking equation. Well, the plus or minus might be a little funny, but it just means you have basically two equations in one here. You either have 3x minus 4 is equal to the positive 4, or you have the 3x minus 4 is equal to the negative 4. You actually have two equations here. But these equations are nice, right? Add 4 to both sides. 3x equals 8. Divide both sides by 3. X is equal to 8/3. That's one of your answers. This one, add 4 to both sides. Negative 4 plus 4 is, well, 0 actually. Divide by 3 and you get 0 still. There's your other answer. Wasn't that nice? That was slick. So that's kind of like the shortcut of the week. Shortcut of the week. Okay, well, I hope you're enjoying all this stuff. The next lesson, we're going to look at more factoring. I got to show you this one more kind of factoring, and then we'll kind of be done with this stuff for now. Alex, of course, is giving you lots more information, but it's nice to have, it's just nice to have a nice summary like this, I think. Okay, see what I'm doing is I'm stalling for time so I can figure out how to turn this off.